Welcome to the Urbano Software livestream. My name is Michal Vajc and I will be your host for this show. Today we are taking a deep dive into Shapefile import for Urbano 10. This functionality is available in the Pro versions of Canalys and Hydra as well as Urbano Ultimate. Let us take a look at today's agenda. After this short introduction, we will go right into the live presentation. You can post any question into the chat box and we will try to answer during or after the presentation. Urbano 10 is a full design, calculation and analysis software solution for infrastructure pipe networks that runs directly inside your CAD environment. We have been developing the software for 30 years and we created some distinct functions and workflows for pipe network design. By engaging with our using community, we get real-world insights into current issues and challenges, and this helps us plan and develop practical solutions. Most importantly, Urbano software enables you to design plans and long sections, make flow and hydraulic calculations, analyze and optimize networks, make data queries and custom data selections, connect GIS, CAD design, hydraulic modeling, and BIM into one workflow, and customize most functions, the equipment catalogs, and even the user interface. For today's topic, Shapefile import, you require Urbano Ultimate, Urbano Canalys Pro, or Urbano Hydra Pro program packages. Urbano Ultimate is the full package and the best Urbano software experience, while Canalys Pro is focused on sewage, and Hydra Pro is focused on water. The standard versions of Canalys and Hydra do not have the possibility to import shapefiles. And now I would like to introduce my colleague Rino Nemarnik, who will do the live presentation.
Thank you, Michael, for your introduction. Hi and hello to everyone, and welcome to another Studio Ars Urbano webinar. My name is Rino, and today's topic will be Shapefile import. In the following 50 minutes of live presentation, I will show you 3 different examples. One for sewage network, one for water distribution network, and one for crossings and clashes between existing and imported networks. So let's start with the live presentation. As you can see here in this drawing, we basically have an empty drawing with the sewage system template created in Urbano. And when we talk about drawing the network in Urbano, we have 3 main ways. So first way would be by interactively drawing in plan. Second way would be by conversion of AutoCAD elements, such as 2D or 3D lines and polylines. And the third way would be by importing from some external file source, which can, for example, be S3 shapefile, which is our topic today, or it can be various SQL databases, LandXML, plain text files, and so on. So to import something, we have to create import configurations. And you can first import the nodes or manholes, and then you can import the sections or pipes, or you can import them simultaneously. If we go to new import configuration for the sections, here we can turn on simultaneous node import. So now inside one configuration, we can import both nodes and sections. So let's give it a name to this configuration. I will call it pipes and manholes. And for the data source type, it will be shape import. And now first for the sections, we can search for the file, or I will open the project folder where I have these shape files. And here you can see these shape files. So one for pipes and one for the manholes. So I will take this one for the pipes and just drag and drop it here to this place. And here you can see the data is read from the shape file. And now we can switch to the nodes and repeat the procedure like I showed before. So you can search for the file or just take it and drag and drop it to this place here. And now we see that we have also the data for the nodes. Now the next step would be to connect the data from the source with the data from Urbano software. So we have to find the matching data. So label is name. So I will take name. and ground elevation is in Urbano terrain height. So you can also search for the data. So terrain height and just add it. And now we can map this data. So label is name and ground elevation is terrain height. That's all the data that we have about nodes. So let's now switch back to sections. And again, let's find this data in Urbano. So again, label is name, starting and ending invert elevation. So let's find it. Again, we have starting and ending invert elevation. And then we have some data that is called line. So this stands for pipe run, or basically arbitrary sequence of elements. And in Urbano, the matching data for that is basically array. I will show you later what are these arrays. These are not mandatory data. This is optional data, but you will see it can be very useful if you have such data. You can also import it. So that's it. So now let's connect it. Label is name, starting invert elevation, ending invert elevation, line is array, and now we have diameter data. So we cannot just map diameter data with Urbano pipe diameter, because in Urbano we have pipe catalog. So we will just import this data as user data, and later we will use that user data for binding with the items from the catalog. So that's it. Let's just click OK. And now we can start this import configuration. And we can also define some labels for nodes and sections from the list of the label configurations that we already have created here. So for the sections, I will use length, slope, and diameter. And for the nodes, I will use name, terrain, and invert elevation. So let's just click import. And now in a matter of seconds, we will have all this network imported. Also here you can create location queries. So basically define one closed polyline and import the network just inside that closed polyline. But we imported the whole network here. So let's check it. If we zoom to plan, we can see these nodes and sections labels with all the data. And you can see that we don't have the diameters defined yet, which can be seen in the label. We just imported the information about the diameter that we will use for binding with the pipe catalog. Let's now analyze this system using Urbano data tables. So again, you can see that you can have many different configurations with different data. And then you can just open the data tables. I will select the whole system. You can check all the data about the sections, so lengths, invert elevations, slopes, but we see that we don't have diameters defined yet. Also, we can select the entire network and run recapitulation summary, and we see that in total we have around 38 kilometers of this network that we imported from the Shapefile. Also, we don't have to check the entire system. We can also use Urbano selection options. So of course, our model is consisted of nodes and sections. So for example, we can select just some sections from the model. For example, I will select these 3 sections, and we can check the data just for those sections in the data table. Also, in Urbano, we have some more intelligent selection options. For example, selection of branches or arrays. So let's take a look what is a branch in Urbano. So like the word says, branch is basically everything in between 2 main nodes. So main nodes are beginnings, endings, or branchings. So as you can see from these temporary graphics, you can see what is a branch in Urbano. And this can be very helpful because with selection of one branch, we get all the sections that belong to that one branch. Also, we have something that we call arrays. And like I said, arrays are basically arbitrary sequence of elements that you can define by yourself. So you can see an array can contain branches. They are larger than branches. And you can also import them like I did from the shapefile. So for example, now when I select one array, I will get all the sections that belong to that array. And also I can switch to a special data configuration just for arrays, like this. Let's select the entire network again. Let's sort it by arrays. And now you can see what are these arrays in the network and how they look like. Okay, let's now go back to section geometry. And let's take a look at this slope data. So we see that we have some negative values of the slope. Let's sort this data table to see where these negative slopes are. So the negative slopes, of course, can represent pressure pipelines, but by looking this network, I see that these are not pressure pipelines. This has to be some errors in the original shapefile. We can see that the slopes are negative, and we have these arrows which represents drawing order. They are opposite of the flow direction. So obviously there were some mistakes in the original shapefiles. Basically starting and ending nodes were reversed. So how we can resolve that? Of course, we can reverse one branch by branch, or we can run one really nice function. If we go to edit, fix directions, we can select one exiting node or outfall, which will be this. And now we can click preview, and you will see that all the sections and branches will be reversed so that they go to this outfall here. If I zoom out a little bit and click preview again, you will see how these directions will go. So let's apply now these changes. And now you can see that we don't have any negative slopes anymore in the entire model. Okay, so let's now close this data table and let's now draw profiles. So to draw profiles in Urbano, it's extremely easy. You just have to select profile configuration. And again, you can have multiple configurations with different data inside, different colors, different languages, different scale. I will just select this configuration here. And now I will select the entire system, and you can draw profiles now according to this branch or array topology. So if I go according to arrays, you see 209 profiles can be drawn with just one click of a mouse. Or you can just interactively select some arrays. For example, I will select just these 3 longest arrays in the network, and I will draw them like this. For example, here in one column. And also you can draw profiles by using option from node to node, but I will show you that option later. So let's check now these profiles. You can see all this data. Like I said, everything is defined inside of these profile configurations. And also we can see all the graphical elements like this terrain line and invert elevation, but we see we don't have the pipes defined yet. So let's now use that data that we imported to bind that data with the pipe catalog. To do that, we can go to Tools, bind the data with pipe or manhole catalog, and here we have to find that data that we imported. If you remember, we imported it as user data, so we can just add that data. This is the diameter data. And now we can just click read the data from the entities. And we see that in this network, we have diameters from 200 to 500. And now on the right, we can select the matching Urbano pipe catalog. Of course, it's better if we import more data about the pipes. For now, having just this diameter data, I don't know what is the material of that data, what is the wall thickness, and so on. So the more data that you import, you will have the stronger, better connection rule. But this is enough if you know which pipe catalog this is. And I know these are circular concrete pipes. And now you have to just match it. So 200 will be 200, 300 will be 300, 400 is 400, and 500 is 500. And what is great, as you can see, these rules are saved to catalog. So it's enough to do this only once. And if these are saved to catalog, you will have them for all the future uses of this function. So let's just run this rule. And now we will have the pipes defined for the entire network. Okay, let's now close this and let's now check our network first in plan. So now you will see a dynamic model of Urbano. So everything automatically updated. We see in plan style that we have realistic dimensions of the pipes, and we can see that we have the diameters defined in the labels. Also, if we check our profiles, we can see that the pipes are also defined here. But as we can see, we don't have any manholes defined, and that's because we didn't have any data in the original shapefile about the manholes. Of course, if we had some data, we could use this same procedure to bind that data with the manhole catalog. But because I didn't have any data, I will just set the manholes manually from the manhole catalog. So in the manhole catalog, you can choose between many different shapes of the manholes, different materials, different sizes. I will select this cylindrical manhole with the diameter of 1200, and I will set that manhole to the entire system, to every node. So manholes are now defined, and now we can take a look at those manholes. So we set the same manhole to every node, and also if we go to plan, we can see that the style also automatically updated, now showing us the real dimensions of these manholes here. Also, now if we check the data, so let's open the data table for pipes. Now you can see that we have much more than just one data for diameter. We have all the data about these pipes from the pipe catalog. So we see the group, we see the material, all the diameters, so nominal, inner and outer, wall thickness and everything else. And also if I switch to a data table for manholes, here you can see all the data about the manholes. So again, material, cover and bottom elevation, dimensions, and anything else. Let's now talk a little bit about these profile configurations. Like I said, you can have different configurations in your drawing, and then if necessary, you can easily switch between them. So to do that, I will open a function called Profile Manager, and here you can select all profiles or just some of them, and basically change the configuration with which that profiles were drawn. So now I will just change it, for example, to this standard German configuration. And now you will see everything is in German. Everything looks completely different. We have different colors. We have different data. Let's do it one more time. So now I will change it to some other configuration that I have here. This one is completely in different scale. And now you can again see the scale is much bigger. And we also have some different data, some hydraulic calculation data. So basically anything can be changed and you can make these configurations look as you like. And just imagine if you need, you can have one configuration that we can call design configuration, that you can have some configurations for plotting with different data, or let's say configurations in different language when you design for different market. Also, the similar is for the labels in plan. So like I said, you can have many different configurations and then you can just easily switch between them. So let's change the configuration of the labels, section labels. Let's apply this. And now you can see how it's easy to change the label configuration in plan. Also, let's use, for example, this one for the nodes. So this is the default configuration. And now if I apply this one, you can see it looks completely different. Now we have this invert elevations or invert depths shown on the sections. Or we can even use this style to show invert indexes here on the sections, and the elevations are shown in the label. So many different options. Also, a lot of times this can happen that you have overlapping of the labels. So labels can overlap one with another, or labels can overlap with the topology. Of course, we have functions for moving of the labels, so you can move the labels interactively, or you can open automatic label reposition, define some rules, and just run this function, and all the labels will be automatically moved So there is no more overlapping of the labels in the entire drawing. So we can check the whole drawing and there is no more overlapping of the labels. Also, if you need to have 3D model, you can easily get it. For example, I will just switch here to layout styles. This is the default style that I have applied. So real dimensions of pipes and manholes. And now I will just switch to 3D style. So it's up to you. Urbano has its own model, and it's up to you if you want to show it with AutoCAD blocks and lines, or like I have it here with realistic dimensions of pipes and manholes, or if you want to show it in 3D with AutoCAD 3D solid elements. So now this is switched to 3D solids. And now if we switch to 3D view, we can check the entire network in 3D. But it is important to say that even though these are AutoCAD 3D solid elements, these are still live model. So if you change something, for example, if you increase pipe diameter or change the manhole, everything will automatically be updated. Okay, let's switch back to plan. And now for the final part of this part of the presentation, I will export this model to EPA SWMM software. So let's just write EMP file. Okay, and now I will open SWMM and just drag and drop this file to SWMM, and you can see exactly the same model created in Urbano now in SWMM. You can check all the data. So for the pipes, we see circular pipes with this defined diameter. And also if we click on a manhole, you can see invert elevations and manhole depths defined in Urbano. Okay, so with this, we conclude the first part of this presentation. And now we will switch to a second example today, where we will talk about water distribution network. And again, we will import one water distribution network from Shapefile. So again, to import something, we have to have import configurations, which I already prepared for this example, not to repeat myself, and because I already showed you how you can create these configurations. Now, if we check the original shapefiles for this project, now you can see that we have more than just two shapefiles. So we have, of course, shapefiles for nodes and pipes, but also we have shapefiles for pumps, reservoirs, tanks, valves, vertices, and so on. So I created here a separate import configurations for each of these nodes and node equipments. So if I show you this configuration for the nodes, you can see just like in the previous example, we have name, terrain elevation, but now we also have water demands that we will later use for hydraulic calculation. And also we have some GIS data that I also imported as user data. Also, for all this equipment, so tanks, reservoirs, valves, and pumps, if I show you the configuration, you can see that I turned on this option, set node type or equipment to all nodes automatically. So if we are importing tanks, reservoirs, valves, pumps, this will automatically be set. So from this list, you can choose for each import configuration what you are importing. In this case, these are tanks. And also we have one configuration for pipes and vertices. So we are importing nodes separately and then pipes and vertices in between those nodes. So for the pipes, we have standard data like name, invert elevations, and also data that we will use for binding with the catalog. So material and nominal diameter, and again, some GIS data that we are importing as user data. And for the vertices, in between, we have just name and terrain elevation. So let's now import this network. I will start with tanks. So just click import. And now you can see how this looks like. So we have these custom blocks defined, and that's a block that you can define for each equipment that you are importing. Let's now continue. Let's import reservoirs. Okay, let's import valves. You can see these valves, how they are automatically appearing in the network. Let's now switch to pumps. Again, let's click import. And now let's import all the nodes or the junctions. And now you can see how our network is looking. And now finally, let's import pipes and vertices in between these junctions. So let's click import. And now in a matter of seconds, we will have this entire network imported from the shapefile. Okay, this is now done. And now we can check it. So let's zoom in plan. And here you can see all these custom blocks for pumps, valves, tanks, and also you can see the junctions represented with these circles. And in between the junctions, we have the pipes and we have these vertices. If we check our network again using our data tables, let's open section geometry. And let's again run that recapitulation summary. We can see that in total, our imported network is a little bit longer than 12 kilometers. And again, we can see all the data about the sections except for the diameters because we didn't do the matching yet. But if I switch to a configuration of data for this imported user data, here you can see the data that we imported. So material and nominal diameter. And also we see this standard GIS data that we imported, and this empty data, this is because we don't have all the data written in the original shapefile. So we know that this GIS data can sometimes be missing some data. If we check the data about the nodes, again, let's switch to node geometry. Here we can see coordinates, terrain height, and node types. So now you can see invisible nodes are basically vertices. That's how we call them in Urbano. We see valves, tanks, reservoirs, pumps, and also we see the water demands that we imported for the nodes. Also, let's switch to node user data. And here you can see the data that we imported, this GIS data. And also if we check the topology, I will take the selection of branches. You can see that we have the topology defined. So everything in between two main nodes, two junctions, is one branch. Okay, so that's it. And let's now draw the profiles for this network. And to draw profiles, I will use this configuration. And now I will use option from node to node. I will start drawing from this node, which is a reservoir, all up to this node here. So basically you can draw profiles from node to node in any direction. Let's do one more, again from the reservoir to this node here. Let's place it here. And let's draw one more. Again, I will go from this node. So you can see you can go to any node in any direction. I will go to last node of this system and I will place this profile here. Okay, let's check the profiles a little bit. Again, we can see that we have defined the terrain, invert elevation, but there is no pipes defined yet. So to get the pipes, we have to do that binding process to bind it with the catalog. So let's again go to tools. Let's go to bind the data with the catalog, and let's search for the data that we imported. So let's find it. It's here, and now we have more data. So we will take material and nominal diameter. Let's click read the data. And now you can see that we have some pipes that are ductile iron and some pipes that are PEHD. So on the right, let's search for matching pipe catalogs, ductile iron, and let's say 80 is 80, 100 is 100, 150 is 150. And now let's switch to PEHD pipes and let's match it. 90 is 90 and 110 is 110. These are saved to catalog for later usage. And let's just click on run and everything will be connected to the matching pipes. So now if we go to our profiles, you can see how everything automatically updated And now we also have the pipes shown in the profile. Also, if we open the data table for the pipes, here now you can see all the data from the pipe catalog. We have now different pipe materials. You see all the diameters and all other data about these pipes. Okay, so now we have everything ready to do hydraulic calculation. So to do that, I will switch to Hydra panel. So our module for hydraulic calculation in water distribution networks. Let's open hydraulic calculation and let's just click calculate. It is important to say that for now, let's just ignore these errors. We will talk about this in a minute. But it's important to say that each time you click calculate in Urbano, this EPANET EMP file is created because EPANET calculation engine is built inside of Urbano Hydra. So if you need that model in EPANET, you can just open it directly from the software. And now you can see that each node in Urbano is transferred as junction to EPANET. But if we turn on this option, calculation by branches, now one branch will be one EPANET pipe and only the main nodes will be transferred as junctions and all the invisible nodes will be transferred as vertices. So let's repeat calculation. Let's open it. And now you see we have the identical model in EPANET. You see these multi-line pipes, you see the junctions, and in between we have the vertices. Okay, let's now talk a little bit about these errors. So this is a great functionality because software is automatically telling you where something is wrong or where something is missing. So for example, here we see that these networks are disconnected, which can happen when importing from shapefiles because in GIS data we can have these errors of disconnected elements and stuff like that. So also we can see that we have some missing data about the tanks. So these are hydraulic calculation data. So of course we didn't have it in the original shapefiles. Again, for the valves, we see some missing pressures. For the pumps, we see missing pump curves. We have some pipe diameters missing and also some roughnesses are 0 because we didn't set pipes to those sections. So let's now check those errors. First of all, let's go to this part here where we had that disconnection in the network. If we take a look at this node, it looks like everything is okay. But if we zoom a little bit more, we can see that these are basically two nodes overlapping, but not properly connected. So what we can do here, if I take the function for moving of the node, here you can see that basically we have two nodes. If you check their names in this tooltip. So I will just take one of these and I will move it, for example, here. Now you can see that they are basically disconnected. So to fix this, I will take this function, edit sections, reconnect nodes, select this section, and for the starting node, I will just reconnect it here and click apply. Okay, and now if I take move node again, you will see that now this is properly connected. And this node, I don't need it anymore, so we can just delete it. Let's now check where those pipes were missing. So let's open this pipes data table. Let's sort it by diameters. And now we can see where those pipes are missing. And let's now check why they are missing. Let's switch to our section user data. So data that we imported from Shape. And again, if we sort it by diameters, we can see that for these sections, we didn't have the original data. And that's why we couldn't achieve the connection with the catalog. Let's zoom directly to profile so we can fix this. So these are the sections in question. So not only that we are missing the pipes, we don't have the pipe invert either. So first of all, let's set the invert with this function. We can select area from node to node, and I will just interpolate between these two existing elevations. And let's click apply. Now let's also set the pipes. So I will open the function for setting the pipes from the catalog. I will select the same range from this node to this node. And now you can select pipes from the pipe catalog, or you can use this really nice option for match properties. So I will just select this pipe right before this missing data, and the software will tell me which pipes I have here. So they are ductile iron with nominal diameter 100. So I will set the same pipes here. Okay, so this is solved. And then also we had some missing data about hydraulic equipment. So let's go back to Hydra. Let's go to network elements data. And here we can check all the data about the equipment. We can check the reservoir data, tank data, pump data, and also valve data. So for the tank, we see that we have this data missing. So initial, minimum, and maximum water level. So I will just fill it in. So for all three tanks, I will set initial water level to be 2, minimum water level to be 0.5, and maximum water level to be, let's say, 3. Let's click Save. For the pump, we have to define either pump power or pump curve. Previously, I defined some pump curves for this example, so I will set the same pump curve for all three pumps, but of course you can set different data for each. So I will set this Z1. Let's click Save. Also for the valves, let's define reduced pressure setting to be 40 meters, and let's click Save. And now I think we corrected all the errors. So let's now go back to hydraulic calculation. Again, we will do calculation by branches. Let's click Calculate. And now you can see that we have no more errors here. So we can save it. Also, you can open the model in EPANET if you need it, or in any other hydraulic modeling software that supports IMP file. So that's it. And now you can also check the results in Urbano. So for sections, we see flows, velocities, head losses, and also for the nodes, we can see water demands, head elevations, and pressure in the nodes. Also, we can check the results in our profiles. I will just redraw them so this green frame expands. And now we can check and see how this head elevation looks like using these piezometric lines. So let's check it. So we see that we have all these water tanks and all these pumps bringing additional pressure to this network. So with this, we conclude the second example that I prepared. And now we will switch to a third example where we will talk about crossings and clashes between multiple Urbano pipe infrastructure systems. So here you can see that we already have 3 different systems already designed. These are some existing networks. So you can see in these colors with this legend, what systems are these? So orange is storm sewer, green is drainage, and blue one is water supply. Also, if we check on the right, we have their profiles already drawn. And if we zoom in, we can see that in each profile, we have the relative positions of all the crossed infrastructure. So we have to say that all the crossings and all the clashes in Urbano are completely dynamic and automatic. So if this option, if this label is turned on in the profile configuration, everything about crossings and clashes will automatically appear in profiles. So we have these 3 systems, and now we will import the 4th system, the magenta one, which will be sanitary sewer. Let's show the original shape files. And now you can see that again, I have just one shape file, one for pipes and one for manholes. And also I previously created one import configurations. So again, we have simultaneous import for nodes and sections. And we can see for the sections, we have standard data like name, array, invert elevations. And we have this data about material and nominal diameter that we will use for binding with the catalog. And we have some construction data that we will import as user data. Also, if we switch to nodes, we can see that we have standard data for nodes like name and terrain elevation. But now we also have data about the manholes. So we see manhole cover elevation, manhole bottom elevation and data about manhole description and manhole material that we will use for binding with the manhole catalog of Urbano. And again, some construction data that we imported as user data. So let's now import this system. So I will just click on import and everything will be imported in a matter of seconds. So we can check it in plan. So now you can see it in magenta color. We see this new system automatically appeared after import, but you can see that we have just sections and nodes, but we don't have pipes and manholes defined yet. But if we check these profiles, they automatically updated with the new infrastructure that we imported. So we can see the relative positions of this newly imported magenta system, which is our sanitary system. So like I said, everything is dynamic and completely automatic. Also, let's now draw the profiles for this newly imported network. I will select the whole system and I will draw all the profiles according to this array definition. So let's click draw and let's place these profiles here. Okay, so it's that easy to draw them. And now you can see again that everything is automatic. So all these crossings, all the crossed infrastructure is automatically shown here in the profiles. Of course, we don't have the data about the distance yet, but that's because we didn't set the pipes yet for this new system. Okay, also what you can see here that we have this terrain line because we imported the manhole elevations from the shapefile. But in this drawing, I also have one DTM surface. This is Urbano Terraform DTM surface, but it's also important to say that if you run Urbano on top of Civil 3D, you can also use Civil 3D DTM surfaces as well. So let's now set terrain elevations to this new network from the DTM. So to do that, I will go to input data, terrain heights. I will select the whole network and we will set elevations from DTM. DTM type will be Terraform and we will just click save. And now notice how this terrain line will automatically update, now showing us more elevations. So now you can see that we don't have elevations just in the nodes, but also in between the nodes as well. Okay, let's now bind the information about pipes and manholes with catalog. So again, let's go to tools. Let's go to bind data. And again, let's create a new rule for this types of pipes and manholes. So let's search the user data that we imported. So for the pipes, we imported material and nominal diameter. Let's click read data from the entities. And now we see that, again, we have some different material. Now we have polyester pipes with these diameters. Let's search for the matching catalog. And I have it here. Of course, if you don't have the matching catalog or matching diameters, you can create your own pipe catalog very easily in Urbano, even by importing it from Excel. So let's select these polyester pipes and let's bind this. So 220 will be 220 link, 272 will be 272, 315 will be 315, 530 will be 530, and 750 will be 750. Okay, let's run this connection rule and all the pipes with this data will be matched with the pipe catalog. And now we will repeat the procedure, but now for the manholes. So let's again find the data that we imported about the manholes. So this is the manhole material and manhole description. Let's read the data from the entities. Now we can see that we have just one type of the manhole for this network. And these are some concrete concentric structures with the bottom diameter of 1500 and top diameter of 700 millimeters. In Urbano, the matching catalog is this one, circular manhole with circular open with angle, and 1500 to 700 is this one. Let's link it and let's click run. And now you will see how everything will automatically update. So if we check the plan, you can now see that we have real pipes and real manhole diameters showing in plan. And also if we now check the profiles for our system, for newly imported network, we see that we have the pipes here, and also we have data about pipe distances showing in this label. So here we see that we have some 80 centimeters distance, but here the distance is 0, suggesting that here we have a pipe clash. So that is done for all the profiles. So if we zoom to other system profiles, for example, water supply, now we also see more data for magenta systems. So we see their diameters and also pipe distances. If you need more data about these crossings and clashes, you can go to our special panel, intersection panel, and open the function intersection preview. Here you have this really nice data table where you can just pick inside and check the data about all these crossings and clashes, and you are automatically zoomed to that intersection in plan. You can also check all the data about these crossings, so you can see which elements these are. So these are pipes with pipes, but also you can switch to pipes with manholes or manholes with manholes. Let's switch back to pipes with pipes. Here you can see also which systems these are, which pipes these are, data about those pipes like nominal diameters, or any other data that you want to add to these data tables. Also, you can see one really important data, which pipes are above or below selected pipes. Also, you see which pipes are in direct collision, which means here we have pipe clashes. Also, you can filter the list to show only collisions, or you can even define collision tolerance. Let's set collision tolerance to 10 centimeters. And now here in the list, we have all the elements that are on a distance 10 centimeters or less. Also, it is important to say that all these crossings, clashes, and distances are calculated in 3D. So even though we don't have the 3D style applied in the model, we can switch to 3D view. We can turn on this option to draw elements, intersection elements in 3D. And now when we pick in the data table, we are automatically zoomed to that intersection in 3D, and we can see the shortest distance between these elements in 3D. So these are the distances between the pipes. These are the distances between pipes and manholes. And also we have the same for manholes with manholes. Of course, here we have a lot of clashes. So we would have to fix those problems, but we won't do it now. That's some part of some other presentation. And now for the final part of this presentation, we will export these systems to BIM file formats. To do that, we have to switch to our BIM panel, where we have functions for exporting to IFC, Navisworks NWC, and LandXML. But when we talk about BIM, which stands for Building Information Modeling, it's not just about 3D. So data that describes those 3D elements are as important as 3D. So that's why in Urbano, we have these data configurations where you can create groups of data for export. So previously I created one geometry data group, excavation data group, sewage and water hydraulic data group, and user data group, using the construction data that we imported for these systems as user data. And it's important to say that these configurations can be created once and then used on all of your other projects. So now let's export to IFC, but it's completely the same for Navisworks as well. So you can define what you want to export, so which systems and which surfaces, and also you can define which data groups you would like to export. So I will export geometry data group and user data group. Also, for the project, on the level of IFC file, you can write some data about the project, about the designer, about the company, investor, or anything else. And now you can export all systems to one IFC file or each system to a separate IFC file, which I will do now. And after this is exported, of course, you can open it with any Beam viewer that supports IFC files, but I decided to open it with Autodesk Navisworks. And now you can see how our 4 systems look in Navisworks. So on the left, in the selection tree, you can see all the elements that we exported, so 4 systems and also this Terraform DTM surface. Let's now hide this DTM surface so we can focus just on our pipe networks, and let's check those data groups that we exported. So if I select a pipe and go to Properties dialog, we can check all the data that we exported from Urbano. So geometry data group and user data group. And also if we select a manhole, we can again check user data group and geometry data group. Okay, so with this, we conclude this presentation, we conclude this webinar. I hope you liked it. I hope you would like to test it and try it on your examples. And now, before we switch to Q&A, I will give a final word back to Michael. Thank you all.
Thank you, Rino, for the great presentation. I would just like to emphasize that you can get a free trial of Urbano Ultimate to test the software features by yourself. During the trial, we offer technical support and onboarding to help you learn and use Urbano more efficiently. Before we finish, I would like to invite you to follow us on LinkedIn and YouTube, as we regularly have presentations and discussions around Urbano software. We are also preparing a new type of show that will go live soon. In Urbano Talks, we will showcase our users and the interesting projects they are creating. And this brings us to the end of today's presentation. If you like what you saw, please like, share, and subscribe. And if you have any questions, you can always send us an email or chat message. Okay, so if you have any more questions, just write them into the comments, and we will try to answer. We will be here for a couple of minutes. Also, if you want to have a test version, you can, of course, ask in the chat, or if you have any other kind of question, just you can connect with us through the chat, through LinkedIn. You can also send me an email if you want. So the email is on the screen. Okay, so let me just check. So thank you for all the good wishes about the presentation. We always try to do our best. Of course, this is just a small part of a small selection of what you can actually do with Urbano software. It's best to try it, to use it, and we will help you, of course, with this. Okay, so I would just, on behalf of Rino and myself, I would just like to say thank you all for coming today. It was great to have you, and leave us any question in the chat, and of course, don't forget to subscribe and like the video and share it, of course. Follow us on YouTube or on LinkedIn where you watched, and we, of course, will do our best to deliver more interesting material in the upcoming months. So once again, thank you very much, and have a great day. Goodbye.